Okay, so I'm going to go through and I'm going to try to show you how to make use of some of the abilities to use Matlab to solve some of the equations. So it's come to my attention, I guess, you guys can't use your calculators to solve sort of simultaneous linear equations with your calculators. And so I tried to come up with a way to sort of help you with this. So Matlab is the tool that I'm going to try to use. This was a circuit I looked at in class the other day, okay? And so for this, what I was looking for is the open circuit voltage, okay? So to do that, I used the nodal method. I got two unknown nodes, this node voltage here and this node voltage here. All right, so I went through the process of setting up my two equations. So I've got one KCL. This is for this node right here, okay? And I'll send this to you guys. And then I have another KCL for the open circuit voltage node here. They've got two unknowns, V sub x, the phasor V sub x, and the phasor VOC. I put those in matrix form, and this is matrix form. Let me explain what I've done here. Let's look at this equation right here. Basically what I've got is this complex coefficient multiplying Vx, and this complex coefficient multiplying VOC. So let's see what I wrote. I basically took, here's how I take this. In matrix form, what I say is I have this value right here, okay, multiplying Vx plus this value multiplying VOC equal to 0, okay? In other words, I'm saying this guy here, this term right here, comes from this multiplying Vx, and this term here comes from this guy multiplying VOC, and then the 0 comes over here. If I look at the other equation, again, coefficient times Vx, there's the coefficient, times Vx. There's this coefficient minus j over 40 times VOC equals 120 over 12. All right, so I've got that equation. So let me move that over here to the side so we can still see that. Now here I am. Let me start out in Matlab. So let's say I opened up Matlab. Matlab stands for Matrix Laboratory. It's meant to be able to deal with these sorts of problems nicely. All right, so what I'm going to do is I'm going to click this new button here. I'm going to create a new script. All right, that basically just opens up this window here for me so I can nicely write this out. Okay. What I'm going to do is I'm going to try to type in this matrix right here. So I'm going to create it. I'm going to call it A. All right. What I do is I put it in square brackets like this, and I'm going to write it out line by line. So let me write out the first line. I'm going to say 1 over 60 plus 1 over 12 plus j over 40. So Matlab recognizes j as the imaginary number. I'm going to say comma to get the next entry, minus j over 40. Okay? I'm done with that line. Now I put a semicolon in to say I want to put in another line. And I say now 10 over 120 plus j over 40. And then I would put in the next entry, minus 1 over 120 minus j over 40. Okay? That is the matrix A. That is this matrix. Now, what I want to do now is enter this guy. Okay? What those two equations are equal to. 120 over 12, and then I want another line, so I put a semicolon in there, and then I put a 0. Okay? And notice I'm putting semicolons after each of these, after each line is complete. Now to solve for Vx and VOC, I'm going to say this, x equals the inverse of A times B. So the inverse of this matrix times B is how I solve for this. All right, so now what I'm going to do is I'm going to copy and paste this into Matlab. And so I just paste it in. Okay, and I get my answers. Okay, so look at this. So basically, I said x was my solution vector. It was this vector. The top entry is going to be Vx. The bottom entry is going to be VOC. So let me say x of 1. That's going to give me the top value. That's the value of Vx. If I say x of 2, the bottom entry, that's my answer for VOC. If you look in your book at example 9.10, that's exactly what this circuit is. You look at the answer for that particular problem, you'll see that VOC is equal to this value, 784 minus j times 288. So notice what Matlab did. It shows that it's complex. Even though I entered j in my equations, what Matlab does is it puts an I right there, okay? So hopefully that makes sense what to do. I can also send this problem out to everybody so that they see it, but hopefully this sort of makes sense. The crucial thing of what I did was to write out this matrix and this vector properly, okay? The crucial things, this is the first row. I separated the entries in the row with commas, and I separated each row using semicolons, okay? Same thing here. I separated the rows with semicolons, and then I did this inverse operation, okay? And then I can do, if I want to, you know, various operations. Let's say I wanted to look at I want to see the real part of x of 1 or the imaginary part of x of 1, all right, or the magnitude, I say abs, like is an absolute value of x of 1, okay, 252.98 volts. All right, the crucial thing is that you understand basically this process. 3 steps for how I write this matrix here. The second step is how I write this vector here. And the third step is how I solve to figure out the 2 unknowns. The x of 1, in this case, the top value is this one. X of 2, the bottom value is this one. That's all there is to it. All right, hope that helps.